Assalamualaikum and good morning. We are going to have a look at another exercise. This is for the chapter of clustering. Clustering is one of the data mining tasks whereby it is an unsupervised task. It is different from classification because in clustering there are no pre-classified data. If you remember the BICE computer data set, we have a list of instances or transaction that have variables that predict to certain class, which were by computer or not by computer. So in this case, in clustering, we don't have that pre-classified classes, so-called. So basically, we are just going to search for groups or clusters of data points. Okay. Now, in this example, the question says, use the k-mean algorithm and Euclidean distance to cluster the following 8 examples. So these examples can also, there are basically data points. Okay, so we have 8 points, A1 at the coordinate of 2 and 10, x-axis 2, the y-axis 10. You can also map this in a two-dimensional plane. So basically, we only have the coordinates here. So in k-means clustering, what it does is we want to find the distance between two examples, and we want to so-called groups the examples that are close together. We want to cluster them together. So basically, we have this is called a distance matrix, whereby we want to calculate the distance between A1 to A1, which of course the distance is 0 because it is at its own place. Okay, and we calculate the distance between A1 to A2, which is square root of 25. So where does this square root of 25 comes from? The question will usually gives you the type of distance function or distance function that will be used. There are many distance functions available. The Minkowski distance, Manhattan distance, which in this case we use the Euclidean distance. Most common one. We learned this when we were a lot younger, okay, during our high schools. So basically, if you remember, the Euclidean distance is the square root. Okay, let me just write down. So the distance is the square root. Distance is between 2 points. Okay, so we have point 2, let's say y2 minus y1 squared plus x2 minus x1 squared, or the other way around, doesn't matter. So if we have two points now, A1 and A2, okay, so you'll find that if we map this, can you see this? Okay, let's say this is x, this is y, this is 2, 10. Now assume 2 is here, 10 is here. 2, 10 is A1. And then we map another one. A2 is 2, 5. This is 5. This is A2. So we want to find what are the distance here. Okay. So of course, using the Euclidean distance, we want to find the distance of the y-axis. Okay. Y2, which is 10 minus 5, is 5 square. Plus, sorry, let me do this. X2, what is X2? 2 minus 2, which is 0. So 5 square is 25. So I have the value square root of 25. Well, you can go on and continue the square root of 25, but in this case, I just don't want to get into the nitty-gritty of the decimal point, so I just put it like this. Okay. So given the distance matrix, the question will also give us the initial seed, the center of each cluster. So in this question, the cluster is A1, this one, A1, A4 and A7, A4 and A7. Okay, so we want to find what are the points, where does other points A2, A3, A5, A6 and A8, where does it lies in this plane, and whether they will eventually belong to the seed of cluster 1, cluster 2 and cluster 3. Okay, so in this case there are 3 clusters. So how we calculate, basically we just based on this distance matrix. Now let's start with the first one. Epoch is the iteration. So in the first iteration, we are going to evaluate all the data points or all the examples, and we want to determine whether it goes to cluster A1, A4 or A7. Okay, so for the item A1 or example A1 or the data point A1, the distance between A1 to the seed, what seed? So this is the first seed. I can put cluster 1, I can put seed 1, it doesn't matter. So in this case, the solution calls it seed. So this is seed 1, seed 2 and seed 3. So the distance between item A to seed 1 is 0 because A1 is the seed 1. The distance between A1 to seed 2 is A4. Okay, where is it? A1 to seed 2 is A4, is the square root of 13. And finally, the distance between A1 to seed 3 is A7, A1 to A7, square root of 65. So the value here is greater than 10. So basically A1 is definitely, is greater than 0. So A1 is definitely in cluster 1 because it is the center of cluster 1. Yeah, I wasted my time explaining this. Okay, let's go for cluster 2. For A2, for the second data point, which is A2. So we calculate again the distance between A2 to seed 1. Again, seed 1 is A1, A2 to A1. A2 to A1 is square root 25. And we have distance between A2 to seed 2. Seed 2 is A4. A2 to A4 is square root of 18, and then we find the distance between A2 to seed 3, which is A7. A7 is square root of 10. Okay, so we want to find the smallest one. Why we want to find the smallest one? Because we want the smallest distance. Okay, the smallest distance indicate that they are grouped nearby each other. So we continue calculating for A1, A2, A3, A4. So basically, for item A1, it is in cluster 1. For item 2, it will go to cluster 3. Item 3 will go to cluster 2. Item 4 will go to cluster 2 as well. So if we continue doing this, so finally we'll calculate A7. What is the distance between the point A7 to seed 1, distance A7 to seed 2, A7 to seed 3, and we want to find what is the smallest value. Of course, 0 is the smallest value. So A7 is the cluster 3, then finally A8. This is already the seed. Okay, so finally A8, the distance between A8 to the first seed, second seed, third seed. So between the square root of 5, square root of 2 and square root of 58, square root of 2 is the smallest, and therefore the item A8 will belong to cluster 2. So the new cluster will look like this. A1, only 1. Cluster 2, we collect back who are the data sets or data points that belongs to cluster 2. So now cluster 2 has members A3, A4, A5, A6 and A8, and finally cluster 3, A2 and A7. This is as compared to the original cluster. Remember, original cluster A1, A4 and A7. So before this is only A1, this is only A4, this one is only A7. Okay, but after the first epoch, we get a new cluster. So given this, we want to find, and we iterate. It doesn't work one time only. So we want to iterate and find new clusters, and we want to find what is the center of the new cluster A1, center of new cluster A2, this is the new cluster 2, and this is the new cluster 3. We want to find the center of it. So we just calculate the distance between the center. So basically A1, it is at itself because there's only one element or one data point in cluster 1, which is at position 210. And C2, you have to find add all the x's and y's's, okay, and divide by how many points there exist. Then you get a new coordinate, which is 6, 6, okay, and you continue on doing that. All right. So this is the results of the first epoch. If you see, A1. What is A1? A1 is 210. Yeah, 210. So this is A1, 210, and after the first epoch, basically we get this. We get this new cluster, A1 again. Second cluster is this A34568, A34568, and then the third cluster only 2 data points, A2 and A7. Okay, so we do the second one. Okay, in the second one, we repeat the process, and for this example, you need to do another 2 more iterations. So finally, after the second iteration, you will get the final one, which is this one. Okay, so from this is the first iteration, and in the second iteration, you will get this. The data points kind of move. The algorithm will fine-tune to find smaller distance, keep on continuing. For example, given this new cluster, what is the center, and then they continue on calculating for another epoch. So when does the epoch stop? When there are no more movement. Okay, so which in this case, the movement is up until 3 epoch, 3 iterations. So this is the final answer. But in examinations or in exercises, you depend on the question. If the question asks you to do 1 epoch or 2 epoch or until finish, then good luck. All right, see you next. Bye.